Hello guys, Yulia Bone over here, and we're going to continue with chapter 3 of microeconomics, and today we talk about interdependence and gains from trade, and we're going to learn about how trade makes everybody better off. We already learned in chapter 1, it was one of the principles that trade make everybody better off. In this chapter, we're going to look a little bit more into details, how that actually works, and we're going to use example of two countries that are producing two goods, and using this example, we're going to see how if these two producers start trading, how it's actually make them better off. In this chapter, we're also going to learn about the new kind of theory or definition of absolute advantage. We're also going to talk about what is the comparative advantage. We'll talk about how they're similar and how they're different and how we can apply this absolute or comparative advantage to analyze our trade. So guys, here there is an example of a person, individual, and pretty much, it's saying here that, he has coffee, he has his shirt and his haircut and his cell phone. They actually all made, in different countries. So if you're sitting right now in your room or in your parents' maybe living room, you can probably look around and try to see what is actually made in the United States, or what is actually made, furniture, your book bags, your computers, your water bottles, your cell phones. Where is it all made? And you can probably see and figure out that all those goods are made in different countries. So in our simplified example, we're going to have two countries, Japan and Korea, and they're going to produce two goods, steel and televisions. And how we're going to read this table? This table pretty much is telling us that Japan can produce either 6 units of steel or 3 units of TVs, or anything in between that. They're not giving us kind of points in between, but we don't need that for our analysis. We can actually figure it out later. And Korea can produce either 8 units of steel or 2 units of TV, or anything in between that. But once again, it's not given to us. We can figure it out on our own later. So in order for us to understand how trade makes everybody better off, what are we going to do first? We're going to build our production possibilities frontier. Then we're going to find opportunity cost for both countries, for both products. And then we're going to do the analysis and see how trade is making these two countries better off. So we're going to start with Japan. So Japan is going to have production possibilities frontier. So Japan can produce some units of steel. I'm going to put steel on our vertical line, and Japan can produce also some TVs. I'm going to go ahead and build these coordinates for Korea, and I'm going to be consistent. If I put steel on the vertical line, I'm going to put steel on the vertical line for Korea, and TV for Korea is going to be on the horizontal line the same as I did for Japan. In order not to mess up or not to be confused in our analysis, I'm going to be very consistent. Next, Japan can produce 6 units of steel. So I'm going to take a point and I'm going to say this is 6, and Japan can produce, once again, either 6 units of steel or 3 units of TV. Remember guys, when Japan is producing 6 units of steel, it doesn't produce any TVs. So this is our point indicate on our graph. Japan is producing 6 units of steel and 0 TVs. Or Japan can produce 3 units of steel if we allocate resources differently for Japan, and we're going to concentrate on production only TVs, then Japan can produce 3 units TVs and therefore 0 units of steel. So this point is going to be somewhere over here. I'm just going to put 3, and when I connect these points, that's going to be our production possibilities frontier. Remember, in the previous chapter, we built production possibilities frontier, and we probably had like 5 points on our graph. Here we make it simple, and that's all we need for our analysis. I'm going to go ahead and do the same for Korea. Korea can produce 8 units of steel or 2 units of TVs. I'm going to connect these dots, and it's very easy and simple. This is our production possibilities frontier. Next step in our analysis is going to be we will find opportunity cost for Japan for TVs. And in order for us to do that, we already know in order to find our opportunity cost, we can use slope formula. And slope formula, I'm going to indicate over here, slope formula is equal delta y over delta x. So now we're going to look on our graph and we'll try to figure out what is delta y and what is delta x. Remember, we're working with Japan. So if we're going to be somewhere over here at point A on our graph, and we're going to move all the way over here to point B on our graph, we can calculate what is going to be the change in our y and what is going to be the change in our x. So when we're at point A, our y, remember guys, from algebra and from geometry, vertical line is usually y and horizontal line is actually x. So if we're at point A, our y, or units of steel, is equal to 6. So we have 6 units of steel that we're producing. If we're moving all the way to point B, then how much is going to be our y? Our y is actually becoming 0. So therefore, we're going to do 6 minus 0. This is change for our y. And what is the change for our x? Remember, if we're at point A, how much is our x? Our x is equal to 0. We're not producing any TVs. At point A, we're producing 0 TVs. So therefore, the change is going to be from 0. And then when we move all the way to point B, we gain 3 extra units of TV. Or we're producing 3 TVs right now at point B. So therefore, our change is going to be from 0 to 3. Guys, remember, it's going to be negative. Our delta x is going to be negative. For the purpose of calculating opportunity cost, we just ignore that negative sign. We're taking absolute value, so it's going to be 6 over 3, or it's equal to 2. So how are we going to interpret this number? Opportunity cost of TV is equal to 2. What does it mean? It means that in order to produce 1 TV in Japan, we need to give up 2 units of steel. Guys, remember, any decision that we make, it's going to have a trade-off. And the trade-off is that if we want to produce 1 TV, we need to give up some units of steel. We cannot produce 2 TVs. Let's suppose 2 TVs are going to be somewhere over here. And can we still keep production of 6 units of steel? Let me take a different color over here. Let's suppose we're producing not 2 TVs. I'm sorry. Let's do 1 TV. Okay. If we're producing 1 TV, my question is, can we still keep production of 6 units of steel? And the answer is no, because remember from the previous chapter, this point, this green, let's suppose this is point M, is actually outside of production possibilities frontier, and this point is not possible because we don't have enough resources available. So therefore, in order for us to produce 1 TV, what do we need to do? We need to give up some units of steel. How many units of steel? It's exactly to 2. Then remember, if we want to produce 1 more TV, if we want to increase production TVs to 2 units, what are we going to do? We're going to have to give up another 2 units of steel. So this is going to be 4, this is going to be 2. That's kind of our points on production possibilities frontier. What else do we need to know here? Guys, let's look at this ratio. I usually point this to my students. Let's look at this 6 over 3. Okay, 6 over 3. What does it really tell us? It's telling us that in order to produce 3 TV, we need to give up 6 units of steel. So here you go on the graph. Remember, at point A, we were producing 0 TVs. When we move all the way to point B, all of a sudden we produce 3 TVs. But when we produced 3 TVs, what did we do? We gave up 6 units of steel. So if you take this ratio and you actually divide 6 by 3, now you're going to have your opportunity cost in 1 unit increment. This is telling you that to produce 1 TV, you need to give up 2 units of steel. In this ratio, they were telling you to produce 3 TVs, you need to give up 6 units of steel. All right, keep going. Now we're going to calculate opportunity cost of the other item. We calculate opportunity cost of TV. Now we're going to calculate opportunity cost of steel. And for opportunity cost of steel, it's going to be really easy. What are we going to do? We're just going to take this cost of TV and flip it. It's going to be 1/2. And this one is going to tell us that to produce 1 unit of steel, we need to give up half of TV. I'm going to write it down over here so you can understand. What does this cost mean? It means that to produce 1 unit of steel in Japan, we give up, or we need to give up half of TV. So that's our opportunity cost of TVs and steel for Japan. We're gonna keep moving to Korea. Since we already know how to do it for Japan, for Korea we're going to do it kind of really quick and a little bit faster. Opportunity cost of TV for Korea, I'm going to write down the formula. It's delta y over delta x. I'm going to remind you one more time. When you use the slope formula, delta y over delta x, this is going to be the opportunity cost of whatever item you put on the horizontal line. On horizontal line, I put my TVs, therefore this is going to be opportunity cost of TV. This is common mistakes that students do all the time on the test. So what is my delta y? Delta y is 8. Delta x is 2, and therefore opportunity cost of TV is going to be equal to 4 units in Korea. I'm going to write this down. What does it mean? It means that in order to produce, so I'm going to do this, in order to produce 1 unit of TV in Korea, remember that concerns Korea, we need to give up 4 units of steel. So remember that. And opportunity cost of steel is going to be equal quarter of TV. That one, the second opportunity cost, it's really easy. Okay, so next one, guys, what are we going to do? Next, we're going to compare two opportunity cost, and I know there's a lot of writing on this slide, but we're going to pay attention now to 4 different costs. So we're going to pay attention to opportunity cost of TVs in Japan, to opportunity cost of TVs in Korea. Let me take a different, maybe let's do this. Okay, so opportunity cost of TV in Korea, and then we're going to look at this opportunity cost of steel in Japan and opportunity cost of steel in Korea. And we're going to see which country can produce TVs and steel with lower opportunity cost. In order for us to do that, first we're going to compare TVs in Japan to TVs in Korea. And we see that Japan producing TV at a lower opportunity cost. It means that Japan has a comparative advantage in TVs. Japan figured out how to produce these TVs in a better way at a lower cost. So therefore, Japan is better at producing TVs. We're going to tell that Japan has a comparative advantage in producing TVs. Therefore, Japan should specialize in TVs and export. I'm going to show you the definition just in 1 second. And then we're going to compare opportunity cost of steel in Japan and opportunity cost of steel in Korea. We see that opportunity cost of steel in Korea is lower. So it means that Korea figured out how to produce steel in a better way. So they can produce the steel using less TVs. So therefore, Korea is going to have comparative advantage in production of TVs, and therefore Korea should specialize in TVs and export. So let me put you on another slide and let's talk about comparative advantage. So comparative advantage is the ability to produce a good at a lower opportunity cost. If country have a comparative advantage in that good, so if country is producing a good with the low opportunity cost, it means that country should specialize in production of that good. So Japan should forget about units of steel. Japan is not really good at producing steel. Forget about steel, produce only TVs. Korea should forget about producing TVs. They don't produce it at a lower cost. Japan doing it's actually much better. Korea should concentrate on production of steel and produce only units of steel. So remember this comparative advantage definition. So comparative advantage, this is the ability to produce with the lower opportunity cost. Guys, if you have questions about comparative advantage on your test or on your exam, you have to do calculations. You need to look at your numbers and you need to calculate for opportunity costs. You need to compare them and figure out who has a comparative advantage in production of what good. So let's look at this one more time. Here's our opportunity cost that we calculated a second ago. So comparative advantage, once again, this is comparative advantage. Usually I write it CA. This is ability to produce with the lower opportunity cost. So in order to figure out who has a comparative advantage in production of what good, we need to compare cost of TVs in one country to cost of TVs in the other country. Please don't compare TV in one country and steel in the other country, or don't compare TV in one country and steel in the same country. That's not right. You need to compare one and the same product, apples to apples. Opportunity cost of TV in one country and opportunity cost of TV in the other country. So we said that Japan producing at a low opportunity cost, so therefore Japan has a comparative advantage in production of that product. After that, we're going to compare our units of steel. Japan producing steel and it's using half of TVs. Korea producing steel and they're using only quarter of TV to produce 1 unit of steel. Who has a lower opportunity cost in production of steel? Korea does. So I'm going to say this is comparative advantage for Korea. What does it mean for Korea? Korea should specialize in production of units of steel, okay, specialize in steel and export it to Japan. So keep all this in mind. I want to show you really quick one more kind of trick. Guys, remember when I was building production possibilities frontier, let's suppose I'm going to take Japan. Remember, I said that I put units of steel on my vertical line initially. I'm going to reverse that. Let's suppose that I'm going to put TVs over here and I'm going to put units of steel over here. It doesn't really matter how you indicate your X and Y. It's just when you calculate opportunity cost, please don't make a mistake. So remember, we were producing in Japan, we were producing, I believe it was 3 TVs and I think it was 6 units of steel. So what I'm going to do, I'm going to calculate opportunity cost, remember, of what is on my X line now. On my X line right now, we have steel because I'm using delta Y over delta X. Therefore, this is going to be the opportunity cost, whatever I put on my horizontal line. On my horizontal line, I put units of steel. Therefore, this is going to be opportunity cost of steel. Now, delta Y, remember, is going to be 3. Delta X is 6, so therefore opportunity cost of steel in Japan is going to be 1 over 3. This is exactly as if we calculated in our 6 over 2. I'm sorry. Yes, let's get my math straight over here. It's going to be 6 over 2. This is exactly as if we calculated in our previous example where our coordinates were reversed. So therefore, it doesn't matter if you put steel or TV over here. I just usually like to be consistent, with both countries. And let's look at TVs. Opportunity cost of TV in Japan, remember what we do? We actually flip the number, is equal to 2. Exactly as if we were calculating, in our first example. So I'm going to stop over here. Please make sure that you know what is comparative advantage. How do we calculate opportunity cost? Please know this formula, delta Y over delta X. And we're going to continue in the next video.